let's talk about trees. So we're just going to go over a general understanding of trees, such as ancestors, descendants, siblings, leaves, internal node, children, parents, etc. There's lots of things to cover, but we're not going to cover traversals today, or ordered trees, or AVL trees, like self-balancing trees. Nothing like that. That will be in other videos. Today is just general trees. So this is an example of a tree. So when you're looking at a tree, there are many different things to consider. If you've ever worked with graphs, trees are a type of graph. The nodes are the objects containing the data in the tree, and the edges connect the nodes to one another. In a tree, you can't have anything cyclical. You have the root node, which is a node that has no parents. It's always at the top of the tree. This is a binary tree. So in a binary tree, you may have 0, 1, or 2 children. Any node may have 0, 1, or 2 children. There are many different types of trees that can have different numbers of children, but in this particular tree, we're only going to have a maximum of 2 children. So a child is a node which is connected beneath another node, and a parent is the node which is connected above. So a node may only ever have one parent, but it can have any number of children depending on the type of tree. So this one you can have up to 2 children. No node may have more than one parent. And the root node is the only node in the tree that has 0 parents. So in this tree, 4 is the root node. Its children are 7 and 38. And then 7's children are 6 and 8. So 6 and 8 have the parent of 7, and since they share the same parent, that means that they are sibling nodes. So if we look here, we can see that these two are sibling nodes because they share the parent of 10. 10 is siblings with 5 because it shares the parent of 6. These are sibling nodes here. 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 However, these two are not sibling nodes, even though they're on the same level and they look like they could be. 8 has the parent of 7 and 11 has the parent of 38, so these two are not siblings, they're just on the same level. So each node has one parent and each node may have 0 or more children. How is 4 connected to, say, 5? It may seem like in no way because they're super far away. However, 4 is actually 5's ancestor, and 5 is 4's descendant. So an ancestor would be a node's parent, so 7. 4 would be the parent of 7, which makes it its ancestor. But 4 is also the ancestor of 6 because it's its parent's parent. And it's also the ancestor of 5 because it's its parents' parents' parents. So anything that is rooted below 4, 4 is an ancestor. So if we look here, anything in this tree is a descendant of 4. These two nodes right here, they're descendants of 38. They're children of 38, which also makes them descendants of 38. Now that brings us to subtrees. A subtree is just a node and all of its descendants. So 7, if we took 7 and all of its descendants, that would be everything here. That would create a subtree rooted at 7. If we wanted 6 and all of its descendants, that would create this tree right here. That would create a subtree rooted at 6. We could take 10 and its descendants. That would create a subtree rooted at 10. So that is ancestors, descendants, and subtrees. We also have internal nodes and leaf nodes. So any node that has a child, any amount of children, 1 or more, that makes it an internal node. So 38 is an internal node because it has children. Actually, everything on this tree that isn't an oval is an internal node, except for 8. This is not an internal node because it doesn't have children. But you can see that everything that has a child attached to it is an internal node. They're also called inner nodes, in nodes, and branch nodes, depending on who you're talking to. So anything that has 0 children is a leaf node. So all of these nodes that have black boxes on them and 8, those are all leaf nodes. So if it has 0 children, that makes it a leaf node. Leaf nodes are also often called terminal nodes and external nodes. The last thing that I want to cover is level and height. When you look at a tree and you start indexing from the root at 0, so if I put the level 0 here, 1, 2, 3, and 4. Anything that is on this level is level 0. Anything on this level is level 1. This is level 2. This is level 3. And this is level 4. So it's just indexing a tree starting at the root with 0 is how you get the level of the tree. And then the height of the tree is the number of levels. So here we can see that we have 5 levels. So the height of this tree is 5. That's everything that I wanted to cover in this video today. I hope that this was helpful. If you did get some insight from this video, I would really appreciate if you would give a like and consider subscribing, and I'll see you soon for my next video. Bye.